Hi class 9. So it's been a while since you had a video lesson. I hope you were able to revise the homework I gave in the last class and go through the previous chapters once more. So we'll be starting off with a new unit, and just the first half of that unit we'll cover in this lesson, and that is hydrosphere. So in hydrosphere you have waves, you have tides, and you have ocean currents. So hydrosphere, as you know, is about the water body which is covering the earth's surface, but mainly we'll be learning about the ocean and the role the ocean plays. As you can see here, the syllabus has slightly changed and there are some blank spaces now. So in all the videos before that you have got or you have received from me for geography, you can just go through the lesson what I have taught, but don't follow that syllabus. So if you have any doubts in the syllabus, you can start looking at the syllabus from this chapter onwards, because there's some changes because of uh, the pandemic. There has been some syllabus that has been removed, but if there is, what are the chapters and what are the topics that has been removed, I'll clearly explain it to you during a Zoom session in the next time we meet. But as of now, just go through the syllabus which is displayed over here. So these are the chapters which are not yet completed, and even in the chapters that we have completed already, there has been some portions which have been removed. For example, atmosphere, there has been nothing that has been removed. And in hydrosphere, today we'll be learning about meaning of hydrosphere. What does it mean? What are the different contributors of hydrosphere? Then we have waves and tides, but in syllabus it's written only tides, but you also have waves. Here also you can see that in pollution there's no change, but in the atmospheric chapter with humidity and rainfall and all that, there are some topics which have been removed. As I said earlier, whatever has been removed, I'll let you know clearly in the next Zoom session. Okay, starting off today's class, hydrosphere. You would have heard this term quite a lot of times. Hydro means water, sphere means a realm or an area or a zone. So it's a zone or an area that is containing water, that is having water. So here you can see a pictorial representation or a graphical representation of how much water is there. There's 100% water all around the earth. If we take the total volume of water, there's 100%. But in that 100%, 97.2% belongs to the oceans. So imagine what is left. What's left is very, very less than 3%. It's almost like 2.8% is what is less left. So the area on the surface of Earth where water is present, or which is occupied by water, or which is covered by water, you can write it in any other way, is called hydrosphere. And 97.2% of all the water belongs to the oceans. So wherever you see oceans, it means that it contains maximum or majority of the water. What about the remaining? Even in the remaining 2.15% of water, which is not salt water because it's not from the oceans, it's fresh water, but it is frozen. It's in the form of glaciers, it's in the form of icebergs, it's seen in the tundra, taiga, and polar regions. Permafrost or permanently frozen regions where water is totally frozen. So even in that remaining 2.8, 2.15 goes to permafrost regions. And the last is the remaining 0.65% of water in the hydrosphere is the fresh water that we have, which is in liquid form and which we find under the surface as groundwater, or above the surface through rivers or streams or lakes, or whatever you see, where you see fresh water in liquid form on the surface or under the surface, that has only 0.65% of the whole hydrosphere covering the earth. So that's very less. So you have lakes, you have glaciers, you have oceans, you have underground water, and you know which occupies how much percentage. Moving into waves. So in this chapter, inside hydrosphere, we'll be learning about that 97.2%, that majority of hydrosphere, which is oceans. And in oceans, there are three major movements. One movement is waves, the other movement of water is tides, and the third movement of water is ocean currents. So we'll be learning about the three major movements of water in oceans. Starting off with waves. Waves are horizontal movement of the surface water of the oceans due to the flow of wind. So you know that wind doesn't blow in vertical directions, it blows in horizontal directions. So when there's wind which is blowing horizontally over the surface of the water, it can cause the water to rise and form a wave. So in this picture you can clearly understand that when the waves or wind is blowing, the upper layer of the air sinks and causes a curve on the waves, and the waves have a circular orbit. Each molecule of water inside the waves start rotating in a circular path. So when it starts rotating in a circular path, as you can see another picture underground, you can see the motion of individual water molecules is rotational, circular movement. So when it is moving towards the surface, what happens is when it moves closer to the land, a part of the land is into the water. When it is in deep oceans, the land is way below, but when you go closer to the surface, the land is much more present under the water. So that causes this circular movement of water to become incomplete. So this becomes compressed. If you look at the picture below, you can see that in the left extreme there are four circular movements. It is just implying four individual water molecules which are moving in a circular path. But as it approaches towards the land, what happens is that it starts to compress. It doesn't have all those water molecules doesn't have the space or the area to move circularly. So the land is compressing it, and when it compresses, obviously it has to release its energy in any direction, and the direction it will release is in the upward direction, so the wave begins to rise. That is why in deep oceans you don't have huge waves. Only in coastal areas, so closer to the land, you have huge waves. So you have the upper layer of air that sinks, then you have the waves that move in the circular orbit. Then the highest point of the wave is called the wave crest, the lowest point is called the wave trough. The orbit becomes elliptical due to the shore friction. So the shore is not smooth, it is up and down, it is undulated, so there's friction, and that cracks the wave and causes the wave to rise. So that point where it rises to the point where it cannot continue the circular movement, it breaks. And that is when the wave breaks and it hits the shore, and you see foam or white color um, water which has bubbles and is white in color hitting the shores. So because of the projection of land into the surface, what happens is that the wave breaks and it crashes into the shore. Other wa- Other waves are also formed other than wind. If wind is not the reason why a wave is formed, it can be formed due to tectonic activities. Huge waves, like you would have heard tsunamis, can also be generated by huge tectonic plate movements under the ocean. This triggering movement can displace a huge volume of water. If you look at wind, it can displace only a less amount of water. It can move only a less amount of water. But a huge tectonic movement, land is lifted up or land is suppressed suddenly. There's some crack, some shaking that's happening under the surface. That can lift a huge amount or huge volume of water upwards. And then the water which is lifted upwards will move sidewards towards the nearby land. And such waves or tsunamis will cause severe destruction, and it can cause loss of life and property. So this is the basic understanding of what is waves. The average of height of waves will be just 1.5 to 3 meters, and it depends at what time the waves hit. If it's in early in the morning, it might be lesser. If it's late at night, it might be higher. So it depends upon the timing also. So those are the basic understandings of waves. Okay, what do waves do? We always think that waves just hit the shore, go back. It's a cyclic process which is not benefiting the land, which is not benefiting human beings, which is not benefiting the ocean. No, the waves have a lot of uses. It must look like just a simple cyclic process, but it causes and influences the land and the people in many different ways. Okay, number one, it causes erosion. So if you look at these pictures, you can see all these are different pictures and different structures which are formed by the waves. So one, it causes erosion. When the wave hits the land, it can cause the land to go backwards, or it can take away the soil, break rocks, and you can see that there's in the bottom left you can see sea cliffs which are formed, and the ocean which is hitting the sea cliff. After 10 years, after 15 years, it will start to erode more and more of the sea cliff, and the sea cliff will start moving backwards. So it can cause erosion. Number two, it can shape coastlines. If you look at the second picture on the right, you can see a huge arch which is formed, which is the shape of the coastline. So if there was no waves, the land wouldn't have got this particular shape. That shaping of coastlines also only waves can do. Number three, it can form structures like spits, bars, and tombolos. These are new terms that you'll be hearing. Spits and bars are represented in the top right corner, where you can see a huge sediment or sand being deposited by the ocean inside the ocean. So usually you see beaches or sand being deposited along the coast, but now what has happened is that the water has taken all the sand and sediments from the coast and it has deposited deep inside the ocean as a particular vertical or horizontal line of sediment. So that is called a spit or a bar. And a tombolo is when a huge mainland and a small island is connected by these kind of sediments. If you look at the third picture at the bottom right, you can see there's a mainland and there are people walking in a sedimented portion, and then there is a small island. So if the mainland and the island is connected by sediments which are deposited by the ocean, that's a tombolo. So these are all different structures which are also created by waves. It can transport minerals, for example, minerals which are present deep inside the ocean, which are very costly or which are very valuable, can be deposited or thrown into the shore by the waves. And it can also cause structures due to deposition or due to erosion. I'm sorry. So the structures which you look at the right hand side, whether it be spits or bars or tombolos or shaping of coastlines, all these are caused by deposition. While on the right hand side or on the left hand side, you can see two pictures where one you can see water going into the rock and coming out as a fountain. So that's called a blowout. So a blowout can be a structure which is also caused because of erosion. This is not caused because of deposition, but water is eroding or removing the land. It is forming a new structure. And the picture right at the bottom, which is sea cave or sea cliff or sea arch, all these things, underground sea caves where boating or tourism happens in many countries, all these are erosional structures which are found by the waves. So waves are not just a simple to and fro motion which has no use. It has a lot of uses. It creates a lot of difference on the earth's surface. Moving to the next topic, tides. So what are tides? Most of you wouldn't have seen tides because you wouldn't have gone to coastal areas, but this picture clearly represents what is tides. During the daytime, when the water goes bad or recedes back, the land is exposed, and during evenings or nights, when the water comes more towards the land, the water level rises and it sinks the land. So the water level slowly rising up along the coast and receding later with a definite time period between them. So every day with a different time period, if the water level is going back, it's coming in front, it is rising, it is lowering, that is called tides. It's mainly caused by gravitational pull of the moon and also slightly influenced by the pull of the sun. But mainly it is influenced by the gravitational pull of the moon. When the water reaches its highest level, it's called high tide. At the same time, when the water reaches its lowest level, it's called low tide. So in this picture, you can understand that the picture on the left indicates high tide and the picture on the right indicates low tide. The difference in water level between the high tide and low tide at a particular place is called amplitude or range of tide. So in physics, you would have learned the term amplitude when you learn about waves like sound, or when you learn about the movement of waves, light waves or sound waves, or any other chapter where you learned about waves, the difference between the highest point and the lowest point of a wave would be amplitude. So here the same concept, but it is of tides. The highest point, which is in the picture at the left, you can see the point where the water is ending. If you mark that point, and in the picture at the right, you go deep into, cross the boat and walk into the land and see where the water is ending. You mark that point. So from the distance between this point on the left where the water is ending and the point deep inside in the picture where we can't see the water is ending in the right, you will get a difference. You will get a difference in meters or distance in meters, and that difference is actually the amplitude of a tide, or it's also called the range of tide. Basically, there are two types of tides. High tide and low tide are depending upon the height, but how it is formed, the position of the moon, the position of the sun, the position of the earth, based on that you get two different types of tides, and they are called spring tide and neap tide. So please remember the names. First type is called spring tide and the second type is called neap tide. So the first one, spring tide, you can look at this picture and clearly understand what is a spring tide. So you have the sun and you have the earth, and if the moon is in between the sun or the earth, or if the moon is in between the sun, earth, and after that you get the moon, then the sun, the earth, and the moon will form a straight line. So the concept is not whether the moon must be in between or after. The concept is very simple. If the sun, the moon, and the earth fall in a straight line, what happens is that the gravitational pull will be more, because on one side the sun is pulling, on the other side the moon is pulling. Even if the moon is in between the sun and the earth, there is a double pulling of the sun and the moon, and that causes extremely high tides. Okay, spring tides are produced when the sun, moon, and earth fall on the straight line. So that's the important logic. It should fall on a straight line. This pulls water from the oceans by the sun and by the moon from both sides. And you should also remember that the earth is not gonna stay in this position. Earth is continually gonna rotate. It's gonna rotate in 360 degrees again and again and again. It is rotating. Every 24 hours the earth is rotating. So when it is rotating, the moon will be able to pull water all along the areas which is facing the moon when it is rotating, and the sun also will be able to pull water all along the areas which will be facing the sun during the rotation. So for example, let's imagine the earth is positioned in such a way that the north is the north, the south, east and west, everything is exactly the same directions. So the east and the west, because of rotation, will get maximum high tides, while the north and the south will get very less tides. The combined gravitational effect produces tides that are higher than normal. Since most of the ocean water are pulled towards the sides facing the moon and the sun, the other two sides, which are the other two sides? The sides in the north and the south where nothing is there. Those two sides experience extremely low tides. So the east and the west, I'm just giving directions. For example, the east and the west where you have the moon and the sun, there you have maximum pulling and you have extremely high tides. Where the north and the south where you don't have anything, there's nothing to pull and hence you have low tides. The new moon or the absence of moon and full moon where the whole moon is spotted, in those regions spring tides occur. So where do we get a full moon? You get a full moon when you are in the west. In this picture you can consider, if you are in the eastern side, you will be facing the moon. So you have two moons. Actually there's only one moon, but if the moon is in this position and if the moon is in this position, for that understanding there are two moons. So imagine you are standing in the easternmost region and you're looking at the moon, and where is written full moon, you're looking at the full moon. Because the sunlight is falling on this, you will be able to see the full moon. But at the same time, if you're standing on the west, the sun will fall on one side of the moon and the other side of the moon which you're looking at will be totally dark. So there won't be any moon and hence it will be new moon. So if you are in a position of the earth where you can see the moon fully as full moon, or you cannot see the moon completely as new moon, then you will be experiencing spring tides. If you are in a coastal region, you will be experiencing spring tides, because if you can see a full moon or if you can see a new moon, you are actually standing in a position where the sun, moon and earth are falling on a straight line. Okay, moving on to the second one, neap tide. So the difference is very simple. In spring tide, it had to fall on a straight line. In neap tide, it doesn't have to fall on a straight line. It has to fall on a right angle. So here you can see you don't have two moons. It's just representation of the position of the moon. Either the moon is above or the moon is below, because the moon is also revolving around the earth. Okay, so if the sun is at right angle to the moon, and the sun and the moon are both at right angles or at 90 degrees, then the moon tries to pull in water from one direction and the sun tries to pull in water from another direction, and each pulling tries to cancel out each other, and that creates much more lower tides, which are called neap tides. Neap tides are produced when sun, moon and earth fall at a right angle. So spring tides at a straight line, neap tides at a right angle. This pulls water from the oceans by the sun on one side and is cancelled out by water being pulled by the moon at right angle. So on the spring tide situation, you had sun, moon and earth on the straight line. There was nothing to cancel out, because when we were saying north and south, it was empty. There was nothing to cancel out the pull, and hence it had extremely low tides. But here in neap tide, this is also a rising of water. This is not a low tide. This is also a rising of water only. But when you compare it to spring tide, it is much more smaller. But this is also rising of water. It doesn't rise as much as spring tide. Why doesn't it rise as much as spring tide? Because one side the moon is pulling at a right angle, the sun is also pulling, so it is cancelling out each other. The gravitational pull of the moon is stronger than that of the sun. Hence, the regions where the moon is present, you will have slightly higher tides, and the regions where the sun is present, you will have slightly lower tides. So the regions where the moon is present, it's called lunar tides, and the regions where the sun is present, it's called solar tides. The high tides facing the moon are produced are comparatively smaller than the high tides produced during spring tide. Yeah, so the high tides produced here, that's what I explained before. Even though there's a rising of water, a neap tide will have lesser rising of water compared to a spring tide, because at right angles, sun and moon cancel out each other's pull. Okay, so in that situation, you had full moon and new moon positions to give you spring tides. Here, if you look at the moon and you can see exactly half of the moon, then you are witnessing a third quarter moon or a first quarter moon. You don't have to remember the third quarter moon, first quarter moon terms. You just have to remember, if you're standing in a position and you can see half of the moon, it means that half of the moon is facing the sun. So the moon and the sun are in a right angle. So if that is happening, you are standing in a position where the sun, the moon and the earth are forming a right angle. And if it's a coastal region, you will be getting a neap tide. So the third quarter, half appearance of a moon, and the first quarter, which is also a half appearance of a moon, can be spotted in regions where neap tides occur. So that is the basic difference between spring tide and neap tide. One difference is that one is forming in a straight line, the other one forms at a right angle. The other one is that spring tides are much more higher, neap tides are much more lower. And the other one is that in spring tide, both sun and the moon increase the intensity of the tide. Here they cancel out the intensity of the tide. And the fourth difference is that in spring tide, you either see a full moon or a no moon. Here you only see the half appearance of the moon. Next, moving into another topic, which is the importance of tides. We learned about the importance of waves, which was a lot of new terms and new ideas we learned. Similarly, tides also has so many importances. We'll be learning about 7 very important points of how the tides are helping land and people. Tides helps ships and boats to reach more inland. So because tides are causing water to flow into the land or water to leave the land, it can cause a huge ship which is heavy easily to go into the land or easily to leave the land. So either high tides can help the ships and boats to reach inland because the water is moving into the land, or retreating low tides or water which is moving away from the land can cause boats and ships to leave the harbors easily. Tides take away silt deposited by rivers, reducing sediment deposition. So if you look at this picture, you see river water bringing a lot of sediments from the mountains towards an ocean, and wherever there is high tide and low tide, the ocean water is actually taking the sediments into the deep ocean, and then it is coming and collecting again fresh sediments back into the deep ocean. So every time there's high tide and low tide, the sediment which is dumped by the river can be cleaned or can be removed by the ocean if there is tide. So that's also another very good use or importance of tides. Tides also help in producing tidal energy. So here is the picture of a tidal turbine. So whenever there is increase in water level, it will flow from one side of the turbine to the other side, and it will cause the turbine to rotate. Just like the same concept of a dam. When water is stored and it is flowing from one side to other, it will rotate the turbine. The same concept is happening here. But what happens here is that it is double benefit. When it is high tide, the water will flow from one direction to the other. It will rotate the turbine. When it is low tide, the water will return from that direction to the reverse direction. So from the left to the right, if water is moving in this picture, the turbine will rotate in clockwise or anti-clockwise direction. If it is returning back because of low tide, then also the turbine will rotate. So in both ways, you can produce energy, which is tidal power. Next, in cold countries, tides help water in motion and prevent freezing. So you know that freezing can happen only when water doesn't move. Even if it's a cold river, if the river water is continuously moving, it will not freeze. It will freeze, or the water will freeze only in a situation where the movement of water is blocked. So tides is always moving the ocean water, and it will prevent cold regions, especially harbors and ports of cold regions, from freezing. Here is a picture of a region which is partially frozen but partially not frozen. It is mainly because of the influence of tides. Tides that hit low flat areas can be used to collect and produce salt. So most of the salt pans in our country are regions where tidal or tides are very common. So flat regions. So the another important point is that salt cannot be produced in a region which is uh, undulated, or which is a plateau, or which is like a cliff. It can only be produced in plain regions where there is an ocean, and water comes in, and huge amount of water enters the land, and it can be blocked, and sunlight will be allowed to hit the water, and it will be moved left and right so that it can evaporate fast. So you need a plain, flat, low-lying land. Tide is not only the important thing needed, it must be a flat, low-lying land. Then only huge amount of water will come, and it can be spread out. If it's an undulated land, or if it's a cliff or a plateau, then huge amount of water will not come, and it cannot be spread out like this. So to be spread out like this, you need a huge amount of land. The last point is that tides help in the livelihood of fishermen. So when there's high tides, you can see from this picture, an incoming tide, high tide will cause all the fishes to come more towards the land. So the fishermen don't need to go into the deep oceans to catch fish. And during the outgoing or low tide situations, all the fish go back into the deep ocean. So it helps the fishermen. That's a very, very, very important point, and very important criteria of how it helps livelihood of human beings. So tides increase the chances of fishing more towards or more closer to the land.
Have you gone to the beach and built the coolest sandcastle ever? How many times have you wandered off and come back only to find your awesome creation destroyed? The water was so far away when you started building it. What happened? The culprit was the tide. Tides are the daily rising and falling of the ocean. If you just sat at the beach and stared at the ocean all day and all night, you would notice that the edge of the water would creep higher up the beach for several hours and then fall back down again after several more hours, repeating this pattern over and over. So weird. So why does this happen? Well, tides are actually caused by the same force that keeps us all from floating up into space, gravity. Except this gravity comes mostly from the moon, and the sun too a little, pulling on the Earth. Though the moon is much smaller than the Earth, being only about 1/100th the size, it has a lot of pull because of how close it is to us. Unlike land, the oceans are fluid, and so the water can actually be moved by the force of the moon's gravity. Fortunately, the moon's gravity pull isn't strong enough to pull the water completely off the surface of the planet, A good thing for us, despite how cool it would be to see whales swimming around in space. When the water is at its peak height, this is high tide. Bye-bye sandcastle. High tide occurs when the gravity from the moon attracts water towards it, causing a bulge of water on one side of the planet, while the rotation of the Earth and the moon about one another causes another bulge on the opposite side. Low tide happens as the Earth rotates relative to the moon and the place where you are standing moves away from the bulge. If you pay attention to what the moon is doing in the sky, you may have noticed that it rises later each day than the day before. This is because the moon orbits in the same direction as the Earth spins on its axis. The result is that while it takes 24 hours for the Earth to rotate relative to the Sun, it takes more than 24 hours for the Earth to rotate relative to the moon, about 24 hours and 50 minutes near the equator. Since the tides depend on the moon's gravitational pull, one tide cycle, or the time it takes to go from high to high, or low to low tide, takes half that, about 12 hours and 25 minutes. The time it takes the Earth to rotate so that the place where you are standing on the beach goes from facing the moon to facing away from the moon. Therefore, it takes half of that time, or 6 hours and 12-ish minutes, to go from low to high tide and wipe out your sandcastle. The difference in water height during high and low tide is called the tidal range. If you're playing on a beach in Florida, there is usually a difference of just a few feet in between the tides. The lowest difference between tides is about 3 feet, or 1 meter. In a bunch of places, though, there is a really big difference between the height of the water at high and low tides. The most extreme example is in the Bay of Fundy. This area is known to have a difference of over 53 feet, or 16 meters, between tides. That's like covering and uncovering a 5-story building with water every 6 hours. Because tides are so different in different parts of the world, we need a tidal gauge, an instrument that measures the water level over time. To measure the tides over long enough periods of time that we can learn to predict the tides. Why is there so much of a difference between tidal ranges in different areas? Both Florida and the Bay of Fundy are in the same Atlantic Ocean, right? Well, okay, there are actually a lot of factors that determine both the timing of the tide cycle and the tidal range of an area, like the friction between the water and the ocean floor as the Earth rotates underneath the ocean's tidal bulges, and the shape of the coastline and the depth of the water near the coastline. That's why some places have 2 high tides and 2 low tides every day with an equal tidal range in between. This is called a semi-diurnal tide. And other places have only 1 high tide and 1 low tide a day, known as a diurnal tide. And still other places have 1 or more high or low tides with unequal tidal ranges for each. These are called mixed tides. Remember how I said the sun also has a bit of a role to play in this whole tide thing? Not only do tides operate on a daily scale, but differences in height also occur on a monthly scale too, being dependent on what phase the moon is in and its position in relation to the sun. The highest of the high tides is called a spring tide, as in spring forth or burst forth, not as the season. Spring tides occur when the Earth, Moon, and Sun are lined up in a row, which happens every 2 weeks or so during either a full or a new moon. Neap tides take place when the Moon and the Sun are at 90-degree angles to each other during a quarter or 3/4 moon. The ocean water is pulled in 2 different directions when the Sun and Moon are in these positions, so the tides aren't as extreme. Whew, we've learned a lot. We've learned what creates the tides, what different ones are called, and how to predict them. Who knew all of these celestial bodies and gravitational forces were coming together just to wipe out your sandcastle? Besides affecting your beach day, tides actually impact a lot of our daily lives, from navigating ships, to building bridges, to surfing, and much more. With so much of our lives dependent on the ocean, monitoring this awesome phenomenon is really important and is something you can help do. The next time you go to the beach, try looking up the tides predicted for that beach on that day and see if you can predict when your construction project will be wiped out by the rising tide.
Okay, that video gave a lot of information, and it also told about the types of tides and how many number of tides happen in a day and all that. So all which I have taught before, all those information related to the video, you can learn for your exams. Other is just extra information we just keep to know. And one such of that was, which mentioned in the video, was the Bay of Fundy, which is in Canada, where you see the highest tide in the world. And as you learn about tides, it is very important that you need to know the place where it happens the most, or in the most significant way. So this is the map of Canada, and you will have to know a few places in the map of Canada in the following chapters as well. So in the next chapter, when we learn about ocean currents, you will be needing to know two important places. So in the top, you can see Baffin Island. At the same way, on the right extreme, you can see Newfoundland. So keep these two places in mind. Baffin Island in the north, where a cold ocean current flows, and Newfoundland, which is a very, very important place. It's in the right corner of Canada, where many, many ocean currents meet. So these two places, please keep in mind for the next chapter. But what we'll be discussing now is the Bay of Fundy. So Bay of Fundy, which you can see in the bottom right corner, the Bay of Fundy is a place where the highest tides are seen in the whole world. And just like how they mentioned, the friction of the land under the ocean, or how much water column is there under the ocean, or the position of the moon with respect to the Bay of Fundy, all can be reasons why this place experiences maximum amount of water or maximum amount of tides. So please understand that this is almost the border of United States of America and Canada. Next to that, you can see Quebec, and close to Quebec you can see a red dotted line, which is actually the border of United States of America and Canada. But the Bay of Fundy falls within Canada. What happens? What actually happens in the Bay of Fundy? The highest tides in the world can be found in the northeastern border of USA and Canada. So the black line which just separates is actually the border. So you can see places like Maine, Boston, all these are parts of America. But Halifa and Nova Scotia, all these places, and the water body which is squared up in a red color box, all which is Bay of Fundy, all those regions fall in Canada. So it's actually in the border of Canada and USA, but Bay of Fundy falls within Canada. It is seen in Canada's Bay of Fundy in Nova Scotia. So you can see the picture where here there is low tide, and after some time there's high tide and the whole area is covered. So this is just a small picture, but now you'll see a video of how significantly this place changes. So you can understand that here the tides increase up to a maximum of 16 meters or even 17 meters. So if you look at the picture in the bottom left, you can see 6 meters, 7 meters, 8 meters, 9 meters, 10 meters. So it's not the distance that is being mentioned, it is the height. So 6 meter increase in high tide. If there's another 1 meter increase, which is 7 meters, the water will come till here. If there's 1 more meter increase, it will come till the spring tidal range. If there's 1 more meter increase and it reaches 9 meters, it will come till the St. John Point. If there's 1 more meter increase, so you can see that whenever there's 1 meter increase, the water is coming more and more towards the land. So this 16 meters is not the distance, it is actually the height. It is increasing 16 meters in vertically in height. So that's literally almost in the video it was saying that it was a 5-story building can be covered in 16-meter height. So you'll watch a video and that will be the last slide, and with that this part of the chapter will be over. So the second half of this chapter of ocean currents you'll be seeing in the next video lesson.
This is where we are, at a completely empty ocean.
Yes, here in Canada, they have the highest tides in the world.
The highest. Which means every day the water drops by up to 16 meters and the ocean disappears for miles.
Can't touch this.
And with no water, people go for long walks on the ocean. Others go for mudsliding and others go for meditation. And when the water comes back in, it gets even more The tide creates one of the most fascinating phenomena.
This is like waves in the middle of the river.
A wave that comes out of nowhere that you can ride. This is very fun, this is very unique,
And very rare.
the highest tides in the world will take your breath away.
Can't touch this.
The world is an amazing place, but this part of it is even more so.